Alright, so in this video we will see how to use the official Raspberry Pi Picos datasheet. So this is the Raspberry Pi Picos RP2040's official datasheet. You can download it from their website, or it is available in my website also. You can go download and you can use this for multiple purpose. Okay, so I'm using this in Google Chrome. If you have Adobe or any other PDF reader, anything is fine, but I'll give you some simple thing which you already know. You can always use this table of contents. You press this button, you get table of contents. You can easily switch between the units, right? So let's take a very basic unit, chapter 1. This we have already covered in the presentation. This will give you almost every information. This particular data sheet is it has around 634 pages, so which means that almost every information that you need to know about this particular microcontroller is already available inside, right? So why this particular chip is called RP2040, what does 2 stands for, what does 0 stands for, 40, why they are called 2040, the recent version is has a different number. Why it has different number, you can find it in the NIST data sheet, but here the intention is to help you understand what the chip is, how things are arranged. You get this information first hand from the industry itself. So if you see this is the architectural diagram, the block diagram, how the processor is, how the bus fabric is, memories, PIOs, peripherals, GPIO, the clock generation part. So this put together is your microcontroller, and in the brain of the microcontroller is the microprocessor, which is 2 core. There are 2 cores, processor 0 and processor 1, right? So these are all these things we have already seen. Now there are certain things which you are supposed to know in addition to the common information. You will always come across words that are in blue color. So whenever you see text in blue color, it means that something has been hyperlinked to it. For example, figure 4, if I press, it's taking me to figure 4, right? Similarly, you'll also come across texts in red color. Okay, so if you see a text in red color, it means that it is a register. Okay, any register that is mentioned in the text part or in the paragraph will always be in red color. You can see here, bus control performance register, bus control performance register, right? Whereas if you see in the list of registers like this, it will not be in red. Okay, so that thing you have to take care. And again, the addresses also will be in red color, right? Now let us see how to use this data sheet, how to use, or how to you make use of this data sheet to do register level programming. Okay, so let's say I want to do some operation in the bus fabric, right? So if I want to do like a setting priority, let's take this. Okay, so this is a bus fabric which we have already studied. So if you see, you have core 0, core 1, and then DMA write, DMA read, right? So you have 1, 2, 3, 4, there's 4 things sitting at the center, right? So these are the ones who you can say will request the high bandwidth bus, right? So let's say there is one bus which has very high bandwidth, right? If core 0 requests and if core 1 request or DMA 1 request, DMA read request or write request, if all the requests come at one particular time, who should get the first priority? That I can set. As a programmer, we can set it, right? So how do we set? All you have to do is you have to find the appropriate registers, right? So here in this table of contents, you can go to bus fabric. If you click it, if you open this, you can see at the bottom list of registers, right? So these are the list of registers for bus fabric, and they start at the address of 0x40030000. You'll have 0x followed by 8 individual bits. Okay, it's not actually bits, it's hexadecimal number. Okay, so 8 values. Now if I go to this address, I'll reach a common register. In that common register, 00 corresponds to bus priority, 04 corresponds to bus priority acknowledgement, and 08 for performance counter of the bus fabric, performance selection. Like that, we have multiple registers. Each register will have its own offset address. So where to which register you want to go, you'll have to find that register's base address as well as the offset address. You'll have to add them. When you add them, this is something very important you should keep in your mind. When you add them, you are not going to do a normal addition, not a decimal addition. We are going to perform a hexadecimal addition. In a hexadecimal addition, 4 plus 5 is 9, 4 plus 6 is 10, whereas in hexadecimal 4 plus 5 is 9, but 4 plus 6 is not 10, we call it as EA, right? So when you encounter such kind of values, you should make sure you are doing addition in hexadecimal. You can see here, see, after 8 there is a 4-bit difference, it is becoming C. Okay, after C you should have D, E, F, and then the next bit. C is there, D, E, F, next bit is actually 10. Okay, we don't call 10 as 10 in hexadecimal, it's 10, right? Then after 10, after 10, 11, 12, 13, 14, right? So each are 4-bit, there is a reason for it, and this is how you use the address. You actually add the offset address to the base address, and based on that appropriate address, the appropriate register will open. Now we have opened the bus control register by choosing appropriate address. So here if you see, look at this table, you have to notice bits, name, description, type, and reset. What does each mean? So bits mean what the individual bit is going to do. So every register has 32 bits. We know Raspberry Pi because a 32-bit microcontroller. So each and every register will have 32 bits. So you have 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 31. 0 to 31, so 32. And the name is what is the role of that particular bit. So 0th bit corresponds to processor 0. 4th bit corresponds to processor 1. 8, DMA read. 12, DMA write. So here, it does not mean that processor 0 is connected here. It says that we can set the priority of the master for bus arbitration. Who should get the access of the bus? To set the priority for bus selection alone, 0 corresponds to processor 0. So here you have description. In description, if you give 0, that is if you give 0 in this 0th bit, this will get lowest priority. Whereas if you give 1, this will get highest priority. Right. Another thing is type. What type of register it is? Whether I can read or write, or only read or only write, that will be given here. You have to carefully see it. In certain registers we cannot write, in certain registers we can only read, right? In certain register we can only write. There are certain registers like that, so you'll have to see that properly. In this register you can both read and write, so you can read what is the status already available, or if you want you can write the value also. And then what happens when I reset the entire microcontroller? When you reset the entire microcontroller, everything will become 0, so everything gets low priority. So if I want to set higher priority to few of this masters, I can set it using this appropriate register, right? Now let's take another example, bus control bus priority acknowledgement register. So in this acknowledgement register, we have only 0 bit. The other bits are reserved. Okay, similar to this. These bits are reserved, which means we cannot use it, right? So this bit is registered. What it's saying is that this becomes 1 when you have already set a priority. If you have already set priority in this register, this will automatically become 1. So here, see, this is only read only, RO, read only. So I can only read whether I have set a priority or not. I cannot write in this particular register, right? Again, as before, when I reset, this will become 0. Like that, each and every registers will have its own role. If you read it, you'll get a better understanding. Okay, at this point I would like to add about address mapping also. So this is also very important. See, address mapping is like telling which particular hardware is in which place. Okay, you can think it like a Google map. We are in India, we know where Pakistan is, we know where our other neighboring countries like Sri Lanka is, where Bangladesh is, where Nepal is, where America is. So we have the latitude and longitude to locate that right? Similarly, you have your main processor. That processor needs the support of other small devices, right? So I have to know its address to make use of it, right? So that address is the base address plus offset address. Like your latitude and longitude, this is base address plus offset address. So this will give you a base address where the ROM is, where HIP is, where static RAM is, where advanced performance bus and the peripheral is, high performance peripherals, input output port, Cortex M0, the main processor's internal registers. The entire starting address they have given here. Let's take this, okay, processor subsystem. This is what we've been seeing, right? If I want to do a specific operation, core 0 operation, we have seen in one of our previous video, right? Should be here. A Cortex 0 list of register. So as seen, you can see here 0xE00. That is what it was mentioned in the address mapping also, right? So this is how you use the data sheet, right? You get lots and lots of information beyond your classroom and beyond the presentations that was shared earlier. So please go through the data sheet and get as many as information as possible, right? Thank you.